Hello there, everyone. Hope you're all doing great. We at Zifo have built a native app in Snowflake that engineers de novo antibody sequences with the help of AI/ML models. Without further ado, let's jump into the demo. You can download and install our application from the marketplace and see the application listed under the Apps section. When clicked, it redirects to the setup page of the application. Once in, grant all the necessary account privileges and EAI to successfully launch the application. If needed, provide access to other account roles as this app is currently installed by the account admin role. Now let's launch the application. This setup app has 3 pages. The main page where the resource details and the start of the resource, the log of the services, and the final URL of the antibody engineering application resides. The settings page is where the resource management happens. And finally, we've got a support page that has a SQL editor for troubleshooting. Let's go back to the main page and see the magic happen when the URL is hit. First, let's start the service, which in turn starts the compute pool associated with. If you want to see the status of the resources, you can just refresh this application, which in turn shows you all the resources and its status. Once the service is running, the logs are displayed dynamically, and once that is done, the Streamlit application's URL will be displayed for use. Voila, the URL is up and ready. All you have to do is copy to the clipboard and paste it in another tab. The Antibody engineering application is ready for your use. This Streamlit application has 4 different pages. The first is the home page, which comprises of a brief description on this application, along with the architecture diagrams. It also has a user guide on how to use this application for each page step by step. And we also have a short description on all the models that has been used in this application. Currently, we have 3 different models available: ESM2, ProutGPT, and RoBERTa. Let's jump into fine-tuning of these protein models. As already said, we have 3 different models currently available, among which, for now, I will choose ESM2 model. We also have 3 different input methods. You can either use default data or upload a file from your local system or fetch tables from your Snowflake account. For now, let me just go with using of default data. To see what this default data looks like, you can click on this download CSV file, which downloads you the OAS data we have packaged along with this application. You can save your model with whichever name that you desire into your stage. 3 different parameters are required for fine-tuning a model. You can tune these parameters to get better results of the fine-tuned model. First, let me just go with 100 steps. For fine-tuning, what each of these parameters mean is given in these help buttons when you click on Run Fine-Tuning. The fine-tuning of ESM2 model starts in the backend. You can also see the current running epoch of fine-tuning of this model. Once the training is complete, the model files will be put into your stage. You can also see the results of your fine-tuning. Let's generate the antibody sequence with the model that we fine-tuned. Here, you can select whichever model type that you want to generate the sequence for, and you can select which fine-tuned model that you want to use to generate the sequence and structure. The heavy chain and light chain sequence templates are also given. You can select the number of sequences that you want to generate for now. Let's just leave it at 2, and you can provide whichever name that you want to save these sequences and structures under. When you click on this Generate Sequence or Structure, once the generation is done, you can see the sequences generated along with its corresponding structures. Can switch between these structures, and you can also download the corresponding PDB file of these structures. There are various visualizations that you can choose from. And you can hide or display the side chains and main chains if needed. The anarchy results of heavy and light chain that we've generated are also here, downloadable. You can also see the validation table in here. The CDR results are displayed, and the generated sequences are also displayed. Both of them are downloadable. Finally, let's go to the troubleshooting page. In here, you can download the log scripts. You can also contact us via this email, and if needed, you can troubleshoot on spot using this Jupyter notebook that we have attached here. This is the notebook that you can make use of. We have given few pre-existing scripts that you can make use of to see the GPUs that's being used and status of those GPUs. Now, let's go back to the setup page. Back to the setup page. Let's not forget that there are resources that are currently active which we need to turn off or put on hold when we're not in use. So let's just go to the settings page where you can either suspend, resume, or drop your resources currently. Let me just drop the services that are currently running and also the compute pools that are running. Thank you, everyone.